Okay. Here, if I want to open OneDrive, I just need, okay, here there are tabs, right?
Yeah.
Where is OneDrive? Mm, I mean, can I click here or?
Yeah. So Jim, yes, I just
Okay, done.
slideshow, I guess, right?
Yeah, I think from current slide. Done finally. Hi everyone, this is Harika Thota, and this is my first in-person class for the PDS. So I'll be teaching Tuesday and Thursday sections. So we discussed about like introduction to data science and course metadata in the first week, right? So if you have any doubts, I can wait for a few minutes. And people in online, so if you have any doubts, you can just unmute and you can ask the doubts, whether it's related to project teams. If you have any doubts, you can just unmute and you can ask. And people here, any doubts related to first week? Yep. Yes, we will take care of that. Okay. I think the deadline is coming Friday. So if anyone didn't form the teams, we will take care of that. Okay. Fine. Let's start today class. Okay. So today we're gonna discuss about intro to Python. So this class is going to be, somewhat like coding, but you no need to take any stress. Just listen the concepts. You need not to memorize anything. This class is just to introduce the basics so that if you take any classes like completely Python based, so that you can understand the basics, right? For example, in business analytics, there is a course completely concentrating on Python. So when you take such kind of courses, these slides will definitely help you to understand the basics. Okay. So last week we said to install Anaconda. I think everyone did that. So we're gonna discuss about the Jupyter notebook. We will be using the Jupyter notebook for the entire class for the for programming part. Oh, I'm not doing that. 1 second. Okay. Done. Okay. So when you open the Jupyter notebook, this is the page basically you see, right? So we have like several options. When you write the code with the help of the save button, you can save the file. And the new block is basically used to enter the code. Like if you write the code in one block and if you want to write the code, like another part of the code in next part, you can just simply click on the new block so that the next cell will appear and you can write the code there. And cut, copy, paste, these are just the basics. We all know about that, right? We can cut the cell and we can copy and we can paste after writing the code. And move block, like for example, if you have written all the code, like there will be like 4 to 5 cells. And if you want to move the cell from one place to another place, if you want to move from one point to another point, with the help of move block, you can use that option to move the cells. And next, execution. So in order to run the code, you just need to click on the run button so that your code will be executed. And stop. So if you want to stop the execution at any point, you can use that button. And the reset block, basically, like for example, if you have written some code like a equal to b, I mean like a equal to 10 and b equal to 5. And after that, when you clicked on that reset button, the cell will still appear. But if you try to print like print A, print B, that you already gave the variables, right? You already gave A equal to 10 and B equal to 5, and you click the button like reset, and next in the next cell you are trying to print A. because it's still appearing. But as you reset the block, it will give the error like A is undefined. So the reset block is basically used to reset everything. The kernel will lost everything once the reset block is clicked. Next, Markdown. Markdown is basically used to keep like headings. If you want to keep heading for your code, there are like several options in the Markdown. If you open Jupyter Notebook and if you click on that Markdown, there will be like few options like code, heading, and some raw NB convert. So those options are basically used based upon, like based upon what you need. If you need heading, you can click on the heading option and you can write the heading, and just you need to click the run. So these are some basics related to a Jupyter Notebook. So if you just open the Jupyter Notebook, you can see all the options and you can just go through that all the blocks. Okay. And Google Colab. Actually, we don't discuss about this Google Colab now. In future, if you need Google Colab while doing the projects, I will explain you, you know, regarding this in detail. So, but just for now, you can just skip because it's not important in today's class. So coming to Python, okay, we all know that it is invented in Netherlands and it is invented in 1991 by Guido van Rossum. Basically, anyone in the online or in the class know why he named the programming language as Python? Uh, Anyone have any idea why he named only Python? No. Okay, so no one. So basically, uh, Guido, when he was writing, he's a huge fan of a British comedy series, which is Monty Python. I think many of aware of that. So as he's huge fan of that series, as he's writing a program, so he want to keep his programming language as Python. So that is the the history behind the name Python. And coming to the basics, we all know that Python is an interpreter language, right? It will execute the code line by line compared to Java. So in the like in Java or in like C++ or C, basically we used to write some functions and we used to execute that. But in Python, like we used to execute every line. And just the high level language, we all know that. And Python is basically used in all AI and data science because of the libraries. Because there are several libraries in Python, right? In pandas, NumPy, Matplotlib. We will discuss about that in further classes. And next. Okay, so coming to ideally, like basically one used to write Python in different ways, right? Like some used to write on Jupyter Notebook, some will use, PyCharm, some will use Spider. Python is very easy, like it's just the easy user interface. So if you want to do like addition, we just need to print 3 plus 3. That's all. We will get 6. We need not to write anything. It's a simple and easy interpreter language. Oh, I don't know. Actually, there used to be some figure here. I don't know. I missed. Okay, next. Okay, okay, sorry. Um, okay, so coming to errors, basically, we all know that it's very important to know about errors in any programming language. And this is related to, the history of the errors. Basically, we call the errors as bugs. And anyone have any idea why we called or why the name bug has came, like why they kept the word bug? The thing is, in the early days, when they are writing the program used to crash. So what they did, they used to open the computer and they used to find some fly, a small fly in the computer, and and later they identified that okay, it is stopping the program. Because when the program crashes, they used to open the computer and they found a small bug. And That is the reason whenever a program crashes, they used to keep the name as bug or errors. Okay, there are three types of bugs or errors, mainly syntax errors and runtime errors and semantic errors. Syntax errors, we already know about that. Basically, syntax errors are basically when the structure of the program is not good. So you used to write the program, but the structure is wrong. Then we used to get the syntax errors. For example, you initialize a equal to something 3 and b equal to 0, and you perform print a by b. What you will get? Like if you initialize a equal to 3 and b equal to 0, you are printing a by b. Do you have any idea like which error we will get? Yeah, like in Python, it is zero division error. Because if you divide something by 0, we can't divide, right? Like 1 by 0, 2 by 0, 3 by 0. So it is an error. So it comes under the runtime errors. And coming to the syntax errors, if you want to write something, for example, you want to write print hello world and you forgot to give the single quotes or double quotes, definitely you will get an error, right? That error is related to syntax errors. And coming to semantic errors is basically it's a logic error. The computer will not generate error. I will give you an example. For example, if you initialize a equal to 5 and b equal to 2, if you observe the print statement, we are doing a minus b, right? But what we are given in that sum of a and b. Are we doing sum of a and b? No, we are doing a minus b. But what it will print? Sum of a and b is, what is 5 minus 2? 3. But basically what it should be, like difference of a and b is 3, right? So such kind of errors are known as semantic error. Okay. So now we will see some like Jupyter examples showing all type of errors. If you observe runtime errors, as I explained you before, a equal to 5, b equal to 0, and we are trying to print a by b, the Python will give you an error which is zero division error. And next, another type of error is type error. So just listen to this type of errors and understand. You need not to memorize anything because in the exams there won't be any coding part. Okay. And type errors. Type error is basically if you want to add any string to the integer. For example, I consider a string. Actually, I mentioned like string as a string. Like for example, if you consider a name like Thomas and you are trying to add 10 to it, like plus 10, it will lead to an error, which is type error, because we can't add the string and an integer. You can add two strings, like if you gave like a equal to hello and b equal to like world, and if you can print a plus b like hello world, but you can't add a number to a string. Okay. And next, index error. Index error, actually, it's very important to know about the index error because we always used to deal with lists in, not only in this class, basically when you are doing any programming languages, we will generally use lists, strings, and tuples. Okay. So I gave, here we consider a list like 1, 2, 3, 4, 5, and I printed the length of the list. So we all know that the length of the list is 5 because the indexing in programming languages, it starts at 0. So 0, 1, 2, like 0, 1, I mean length of the list, right? So 1, 2, 3, 4, 5, like 5 elements, but the indexing starts at 0. I'm trying to print the fifth element. Basically, there are only 4 elements, right? Because as the index starts at 0, so it's 0, 1, 2, 3, 4. Like only 4 elements. But I'm trying to print the fifth element, which is out of the range. That is the reason I got an error like index error. And next, key error. Before discussing about the key error, we want to discuss about what is a dictionary. In a dictionaries, we have keys and values. Here, I initialized a dictionary, which is A as 1, B as 0. B as 2. In a dictionary, we have key value pairs. A is a key, 1 is the value. B is a key, 2 is the value. And next, in the second line, I'm trying to print my dictionary like C. I did not give that key, right? I only gave A and B. I did not give C. So that is the reason I I got the error like key error, which is C. Attribute error. So attribute error is basically when like non-existent attribute of an object is assessed. I will explain you in simple. I consider num equal to 5 and I try to append. Anyone know the full form of the append? What does it mean? Append basically refers to appear at the end. In short, it is append. We are trying to add 5 and clearly I mentioned int object has no attribute append. That is the reason we are going to get the attribute errors. And next, import. We all know that when we are dealing with the libraries, pandas, numpy, for any task, like if you are doing data collection, first you need to read the data, right? So for that, you need to import pandas. So import statement is basically used in order to import the necessary libraries that are required for the task to be performed. Here, if I if I use like import Thomas, Thomas is a name. It's not the modules, right? So that is the reason I got an error. No module named Thomas. So if you want to, if you are trying to import something which is not already present, then you will get the module error, which is like module not found error. Next, file not found error. So when you are trying to access a file that does not exist, then we will get file not found error and overflow error. So overflow error is basically when the calculation exceeds the maximum limit. For example, sorry. For example, I imported max. So, and next I'm trying to print max exponential like 1000. So I got an error like it exceeded the limit. And for example, if I replace that 1000 with 100, I won't get any error because it is within the limit. So when you are trying to exceed the maximum limit for a particular range, you will get overflow error. Memory error. Yeah. So this memory error, actually you can try in the Jupyter notebook. Simply if you just retype that statement, you will get kernel died. If you open the Jupyter notebook, we have the kernel option at the, at the top right. So if you are trying to run that large list equal to 1 into 10, 10 power 10, as it is a, like memory error, it will give an error like kernel is dead. So you can't get the output. And next, recursion error. Before discussing the recursion error, what do you mean by a recursive function? So recursive function is basically a function which calls itself. If you observe the recursive function, what it is returning? It is returning the recursive function, right? So it is calling itself. And when we will get the recursion error, if we do that, if you do like infinite recursion, it will get maximum recursion depth exceeded and there is an error which is like recursion error. Next, print hello world and print hello world. First two examples basically explains you that syntax, right? Like what you write in between the quotes doesn't matter. It can be grammatically wrong. It's fine, but the syntax should be clear. In both the, in both the cells, I didn't miss that quotes, right? The single quotes that I mentioned at the end of the hello world, I didn't miss. That is the reason I didn't get that error. But in the third cell, if you observe, what I am missing? I'm missing the, like the starting code for the hello world. And that is the reason I'm getting that syntax error. And example of semantic error, this I already explained, but I'm just showing with the help of the code. I just gave a equal to 5 and b equal to 3, like print sum of a and b, and we are performing the like difference, right? So but it will print like sum of a and b is 2, which is semantically wrong. Next, unbound local error. So unbound local error is basically occurred when you are trying to print an variable before it is assigned. If you observe the example, I define the function example function, and in the next line I'm trying to print the x, but I didn't mention what is the x value. But in the next line I mentioned x equal to 10, but I'm trying to print the x before it is like it is assigned. That is the reason I am getting an error like unbound local error. And here there is an explanation like cannot access local variable x where it is not associated with a value. So simply when you are trying to print something before assigning any value or before declaring it, we will get unbound local error. Next. Okay. Till now, we discussed about lot of types of errors, right? Now we're gonna discuss what do you mean by error handling. Error handling is basically like managing the errors in simple. So we have an error, like how to manage it because we want our program to be executed, right? So there are like three things when we want to discuss about error handling. One is try, you can try except block. Using a try block, you can, you can raise the exception, like you can print what is the error, and next you can run the code. For example, I I mentioned x equal to 5 by 0, right? And I kept that in the try block because I know that it is an error. There is a chance of getting an error. And here in the except I mentioned 0 division error. So it simply print cannot divide by error. So if the user enters 0 at the place of B, it simply print cannot divide by 0. So one type of error handling is using the try block. Second, like what happens, basically we won't write like simple 5 to 6 lines of code. We used to write some like big blocks of code, right? So that is the reason we need something that handles like multiple errors at a time. That is the reason we uses like try, except, and again I mentioned like except. So there is like multiple errors and we are handling like multiple exceptions at a time. So whatever the error part, I will keep that in the try block. And what are the possible errors? I used to keep in the print. I used to keep in that except value error. If there is a value error, and we mentioned like 0 division error if there is a 0 division error. So when you write the code, the possible errors all goes into the block of like exception, and the error code will goes into the part of the try. Next, coming to finally, okay, finally block is basically introduced whether the exception is occurred or not. Like for example, what you write in the finally, whether there is an error or not, what you write in the finally, it will get printed. So before we discussed about like try except, and here we're going to discuss about like try except else and finally. So I mentioned the error coding, like the code which contains the errors in the try block and what type of error it can arise. As I mentioned, like files that may not exist. So it may lead to file not found error, right? So that is the reason I mentioned except file not found error. And I try to print that. Else, if the file is founded successfully, it will print the else block, which is file read successful. So whatever we mentioned in the file, finally, it will definitely done. So the file will be closed. And keywords, it's important to know about the keywords We all know that the keywords are the reserved words in any language. And what are the keywords in Python? And this is how you get how you want to get the keywords if you want to run the code. Like simply if you import like keyword, and if you print like number of keywords, it will just give this list. And this, if you observe the keywords, we have like try, finally, which we discussed just now. And there are total number of 35 keywords in Python. And make sure when we discuss about variables, always make sure you should not use any keywords as a variable name. Okay. Next. Okay. Variable. We all know that in any programming language, what does a variable mean? Variable is generally, if you write a equal to 5, so we are storing the value of 5 in a variable a, right? And there are some rules when you are writing in the variables. First thing, the variables cannot, like cannot start with a digit, right? You can't write 4 equal to like 4 something like 4 Thomas equal to 5, because you are starting the variable name with the digit. So you can't start the variable name with the digit. And this variables concept is very important because you will definitely get a question in the midterm, or maybe I think only in midterm. So definitely one question will be definitely in the exam based on the variables concept. So please concentrate on this. And variables are case sensitive. Okay. There is a difference between myvar and myvar. So if you see the representation, I mentioned like capital V, and in the other word, there is a like lowercase v, right? So both are different. Like caps A is different from the lowercase a. And the next thing, variables can only contain letters, digits, and underscore. So like most of the students, they used to confuse that variables can contain digits. But the thing is, variables cannot start with a digit. Okay. Uh, Please note it down. And next, variable case names are case sensitive, as I already explained, and we will always avoid using keywords as a variable names. Can we start variable names with an underscore? Yes, right? Okay. Done. So these are some examples like valid variable names and invalid variable names. So just observe like current balance. In the valid variable name, I mention underscore after the current. But if you observe the invalid, I mention like hyphen. So which is like hyphens are not allowed in the variable names. Current balance, so this is valid, but current balance, the spaces are not allowed. Okay, like don't get confused. If there is a space, make sure that it's not a valid variable name. And next, account 4, it's a valid, but for account, it's not a valid, as the variable names should not start with a digit. And underscore 42, it's a valid, and the 42, we all know that it cannot begin with a digit. And total sum, it's a valid. And here, if you observe that total, I mentioned like dollar and sum, like special characters are not allowed in the variable names. And hello, this is a valid, but here special characters I mentioned like string, right? I mentioned hello as a string, so it's not allowed in variables. Okay, so we discussed like the theory part. Let's see in the code. So variables in Python, like a equal to 5, b equal to 10. I mentioned 4 account equal to like 2, 3, 4, 5, 6, 7, which is a wrong variable representation. That is the reason we got the syntax error. And next, lambda equal to 6. Keywords cannot be used as a variable name because lambda is a keyword. We can't use it as a variable name. Okay, those are some of the examples related to variables. Okay, coming to operators, there are a lot of operators, and operators are basically used in order to perform the different operations. If you want to do addition, we need arithmetic operators. But if you want to compare 2 to 3 values, we need comparison operators. And like assignment operators, identity operators, like there are several operators. So we will discuss one at a time. Arithmetic operators. So arithmetic operators is just the basic operators which are used to perform addition, subtraction, multiplication, and division. Here we consider A equal to 15 and B equal to 4 and try to do all the arithmetic operations. Addition, I try to add the two numbers. So it's 15 plus 4, 19. And subtraction, 15 minus 4, 11. And multiplication, I try to multiply that. So it's 15 4 the 60. So division, 3.75. And if you observe, there is one more like floor division. So it will give only the integer part, which is 3. If you do division, you will get 3.75. But if you do floor division, you will get 3. And modulus, just the reminder. No, I think it's 4, 3, 5. Okay, quotient. And next exportation, I mean, okay, this is just the power. So I'm trying to print like 15 power 4, which is like 50625, like something. You can try in the Jupyter notebook if you want. There is a sequence for the operators to be performed. So the best known is PEMDAS. Basically, we all know that about PEMDAS. For example, if there is a like long expression 3 plus 2 mentioned in a like braces, and next power 2 plus 2 plus 3 multiplied by 4, if you observe like such long expression, we don't know like which operation we need to perform, whether we need to perform first the subtraction, or we need to perform the addition, or we need to perform the power, or we are like really confused if there is a long expression. We can simply do 3 plus 2 5, but what the rules we need to follow if there is like very long expressions? So there is a rule which is PEMDAS. First, whatever the mentioned in the braces, first that will be executed. Like first we will do that part, and next we will follow the exponent, and next we will multiply, and next divide, and next addition, and next subtraction. And this multiplication and division, they always used to follow from left to right. For example, if you have a long expression, you always start from left to right to do the order of operations. Next, comparison operators. So comparison operators are basically used if you want to compare anything. When you are writing a program, we generally use the comparison operators. Like for example, if you want to compare the salary of one person to another person, definitely we will use the comparison operators, right? So I consider A equal to 10 and B equal to like 2 or 3. I try to print A equal to B. It's false, right? Because both are not equal. And A not equal to B, so which is a true, and A greater than B, false. A less than B, yeah, true. So here and the next one is A greater than or equal to B, which is a false, and A less than or equal to B, which is a true. So these are simply the comparison operators. Logical operators. Logical operators, basically, they used to, like when we discuss about like and or not, logical operators will perform those operations. For example, if you consider A equal to true and B equal to false, and you are trying to do like AND. So anyone have any idea like what the AND operator will do? Yeah, yes. Like if you have 1, 0, 1, 1 and like 0, 1, 1, like what the AND operator will do, like whether the both values are same or not. So if you have 1, 1, then we will get 1, right? So it will check whether there are both are same values or not. So here A and B is false. Okay. And A or B, like as A is true and B is false, and we are performing the AND operator, as both are not the same values, so we will get the false. And or operator basically check, it will verify whether at least one of the condition is met, like A equal to true and B equal to false. So one of the case is true, right? So that is the reason we are getting true and not A. So it will just print the opposite of A, what is mentioned. We mentioned A equal to true, and what it will print, like when we try to print not A, it will print false. Just three logical operators. Okay. Bitwise operators, we all know that the computers, they always used to understand that bitwise operations, only that zeros and ones. So A equal to 10, I mentioned in binary 1, 0, 1, 0, and A equal to 4 in binary, it is 0, 1, 0, 0. Okay. We are trying to print A and B. So it will compare whether the AND operation is met or not. And A or B. And next XOR. And next the complement of A. So it will convert first A, which is 1, 0. Okay. So it just do the complement of A. So whatever the value is there, it will perform the complement of A. And next the print. So it is the binary left shift. And next the binary right shift. So if I simply explain, it will be confusing for you. But if you like take two examples and if you run some code, definitely you guys will understand this example. Okay. Assignment operators. Basically, assignment operators, they are just used to assign values to the variables. So I assign A equal to 5 and I try to print A, and A plus equal to 3, which means A equal to A plus 3. So which is 5 plus 3, 8, and A minus equal to 2. So which is A equal to A minus 2, which is 6. And because 8 minus 2, it is 6, right? And A equal to A into 4. So the A value is 6 in the previous thing. So 6 into 4, it is 24. And next, A divided by 6, so which is 24 by 6, which will give 4.0. As we are using the division, we will get 4.0. But what happens if you use floor division? We will get only 4. We won't get that 0 at the end. Identity operators. So in order to understand the identity operators, basically, if I mention like A equal to 1, 2, 3, what it will happen at the back, they are stored in a particular memory address, right? The equal to 1, 2, 3, I just declared a list. The list A will be stored in a separate memory address. And I mentioned B equal to 1, 2, 3, which is a separate list, but the values are same, right? A equal to 1, 2, 3, B equal to 1, 2, 3. But both are stored in different memory locations. So that is the reason when you try to print A is B, it actually checks whether the memory locations are same. The memory locations are not same. The A value is stored in one memory location and the B is stored in another memory location. And that is the reason we are getting false. Okay. A is C. Yes, because we assigned A equal, like C equal to A, right? So we are assigning both to the same memory address. And that is the reason when we are trying to print A is C, which is a true. A is not B. Yes, A is not B. So it's true, right? It's true, right? So that is the reason we are getting true. Next, membership operators. Membership operators, in simple, it will check whether a particular value is existed in a list or a string. Like for example, here I consider A equal to 1, 2, 3, 4, and I'm trying to print 2 in A. Is 2 in A? Yes, 2 is in the list. And 5 not in A. Of course, 5 is not in the list. So which is also a true, as 5 is not in the list. Next, statements. Mm. Python statements is basically, used for the instructions. Okay, they are the building blocks of Python programs. There are different type of statements. We use the print statement just to print something what is mentioned in that print function. So here I am trying to print the sum of two values. I declared x equal to 10, y equal to 20, and just I am trying to print like sum of 10 and 20 is 30. And variable assignment, in the variable assignment, I just mentioned a equal to 5 and b equal to 10, and I'm trying to print those variables in the print statement. So a equal to 5 and b equal to 10. And conditional statements. Conditional statements, uh, it's just like the comparison. I mentioned x equal to 10 and I'm comparing whether x greater than 5. Conditional statements, they operate based upon the condition. So I mentioned x equal to 10, and if x greater than 5, the first statement will be printed 10 greater than 5, right? So that is the reason the first statement is printed, that is 10 is greater than 5. If not, like what happens if x is, like 4? So it will go to the second, else if x equal to 5, no, because I said x equal to 4. So it will print the last one, like x is less than 5. And next, functions. So we define functions in Python by using the def. I just mentioned add numbers function, and I assign like two parameters, x comma y, and it will return the sum of x and y. As I mentioned, return x plus y. So it will print, I think I gave 10 and 20. Yes, I gave 10 and 20 to the add numbers function. As it returns the sum of two numbers, it will return like 10 and 20 is 30. Okay. And next, loops. We all know about loops, right? In C, C++, in Java. So these are some the basic loops like for loop and while loop. For loop, it basically checks the entire, here I mentioned the range is 1 to 6. So it will check the entire range and it will try to print the everything. So I mentioned the range 1 to 6 and I gave the code like square of I is I power 2. So it will print the square of all numbers until 6. The 6 is not included. And next, while loop. While loop is based upon a specific condition. If the condition is met, it will try to print the code. Classes and objects. Here, I defined a class. I considered the class like calculator, and I mentioned some functions like int, add, subtract. After declaring the functions, I try to add some numbers to that function. So I define the calculator and I try to add 10 to it. So when I so just concentrate on the down part of the code. So I try to add like calc dot add 10. So it will go to that add function and it will print like like as we mentioned, like self dot value equal to num. It means like self dot value equal to self dot value plus num. That is the reason we get like, I think it is calculating the value. Okay, so that is the reason after the calculations we will get the file. I know that most of the stuff is really boring, but the thing is, uh, we basically designed this kind of slides. What we observed from the previous student is they are not even knowing like the Jupyter notebook, like how to write the code. So just as an example, we are simply using this slide. Okay, and import statement. So when you are doing the data collection, so you try to import several libraries. So here I am importing the math and I'm trying to use the square root. So in order to do the square root, I need the math library. That is the reason I'm importing. So it will perform the square root operation and the output you will get is 4. And next, exception handling statements. So I already explained. So I think I need not to explain again. I think I missed a return statement. Okay, return statement, it basically returns something which is already mentioned in the function when you are defining. So here I consider the add function. It will return a plus b. I gave two values to the add function, which is 10 and 20. As return contains a plus b, which is 10 plus 20 equal to 30. Pass statements. Pass statements is basically used if you want to do nothing. And break and continue statements. If you want to break anything when you are writing a loop, for example, for I in range 5, I mentioned a condition, if I equal to 3, just break it and it will print I. And coming to the second part, for I in range 5, I just mentioned if I equal to 2, there is a continue. So it means it will skip this iteration and it will continue. And we will get the output like 0, 1, 2 for the first part and 1, 3, 4 for the second part. Global and non-local statements. Global statements is basically used in order to declare the variables. And delete statement. So delete statement is basically used to delete any particular elements. Okay. Okay. Coming to data types. Data types are basically numbers, sequence, and in the numbers we have integers, float, complex, and in the sequence we have boolean, string, and there is like none. And in the sequence we have list, tuples, range, bytes, mapping like set, frozen set, dictionaries. So in all these data types, like 4 things are very important. Concentrate on tuples, lists, and sets, dictionaries. So these 4 are very important. Rest are like, they have like less importance compared to the one that I mentioned. So strings, we all know the strings. Strings are basically just the names. So if you see your name, it will come under the data type string. They are immutable, means once you declare a string, those can't be changed. And it's just an example, like how the string is represented. Coming to list. List is the collection of ordered and mutable items. In the previous slides, we considered the list in every, like when I explain the statements, when I explain the operators, I gave an example how the list is mentioned. So in a list, it's just the order of elements. Like for example, if you consider the fruits like apple, orange, and mango, those we can keep in a list. And we can also add another data types, like you can also mention like apple 10 and next mango 20. So you can mention any data types in a order in a list. And next, mutable. Yes, once you declare a list, you can change any value in the list. And coming to the syntax, I will explain you in the code. Okay, tuples, basically they are ordered, immutable collection. Unlike list, once you declare a tuple, you can't change it. Okay, once you declare a tuple, it's final. You can't change any value in the tuple. And immutable, as I mentioned, you cannot modify, add, or remove elements once they are created. And they are declared using parentheses with elements separated by commas. Down we mentioned an example like my tuple equal to 1 apple 3.14. So if you see the tuple, it contains like different data types. It is 3.14, it comes under the float, and apple is a string, and 1 is an integer. So like there are different data types that can be mentioned in a tuple. This is the difference between list and tuples. In your free time, just go through this slide because I already explained a lot about both. And dictionary. Coming to the dictionaries, we discussed about the dictionaries in the key value error, right? So I mentioned A as 1 and B as 2, and I try to print the C because I didn't give any value to the C, and I'm trying to print that key. So that leads to an error like key error. So dictionaries contains like key value pairs. If you observe the example, name Alice, age 25, and city New York. Name, age, and city, they comes under the keys. And Alice 25 New York, they comes under the value. So if anyone asks like what is a dictionary, in simple we can say that key value pairs. There are keys, there are values, they are paired. Name and Alice, they are paired, right? So they're key value pairs. And next, mutable. Yes, they are mutable. You can add modify and remove key value pairs. So once you declare a dictionary, you can change the values in that. And must be immutable, keys must be immutable. Okay, the keys must be immutable. Okay. Example strings, numbers, and tuples. Values can be of any data types and can be mutable. So you can change the values, but once you mention the key, those can't be changed. Okay. Comments, basically when you are writing a code, how you mention the comments. In Python, we basically use three types. You can use a single quote or a triple quote. I think, yeah, triple quotes are basically used for multi-line comments, and single line comments by using hash. Python libraries. This is just a brief introduction. We will explain the Python libraries in depth, like when you are doing data collection, data cleaning. In every part of the project, we'll explain you in deep. Python libraries are basically used for data analysis and machine learning. So whatever the stuff that we discussed till now, it's just the basics. You need not to remember anything. You just need to know it. But here, the future slides, it's very important. You just need to know some of the basics. Okay, like pandas, numpy. Numpy, it is basically used for numerical computing. When we are doing any like arrays, matrices, in the data collection, we will consider a data, right? If you are doing a project, we used to give the data sets. The data sets will be in an Excel sheet. So basically, what is an Excel sheet? It's just the arranging of rows and columns. So it is like a matrix. So we are dealing with the mathematical stuff. If you want to deal with any mathematical operations like arrays, matrices, like tensors, we definitely need a library, which is NumPy. It includes all mathematical functions for array operations. So it supports arrays and matrices. So just remember, like whenever there is any mathematical stuff, you need NumPy. Okay. Pandas. Pandas is basically provides the data frame, and it provides like a series of handling tabular and time series. So I gave you the data set and you want to load the data set in your Jupyter notebook. So you definitely need pandas because you need to keep the data, like you used to load the data from an Excel sheet and you used to keep the data in a data frame. And in the data frame, in order to keep that in a data frame, we need the pandas library because whatever the operations that we performed on the data set can only be done after loading the data into a data frame. Before loading, the Excel sheet into the data frame, we can't do any operations. If we want to do the missing values or, like handling the null and removing any, like there are some values in your data set, like which are irregular. The strings may be not mentioned properly. So those kind of stuff we will do with the help of the coding, right? So before doing any type of operations, we need to load the data set in a data frame, and we need pandas for that. So here I mention an example. So import pandas as PD. That is a very basic step you do in the entire coding. You just need to import the pandas as PD. And here I consider a simple data, name, and I mentioned the values in a list, Alice and Bob, and age in a list, 2530. And I loaded the data in a data frame. And if I try to print the data frame, I think we didn't mention that. In the Blackboard, if you see under the slides, there is a Python, the coding file. So in your free time, you just open the file and you just go through that each cell. You can understand how the coding will be related to pandas and NumPy. Next, matplotlib. Matplotlib is basically used if you want to visualize the data. So previous we discussed how to load the data by using data frame. So for that you need pandas. But in order to understand how like what the data contained, like how the distribution is there. So you need matplotlib. And TensorFlow. TensorFlow is basically an end-to-end open source platform for machine learning. TensorFlow will be useful when you are doing a model building. So you studied the data set, you loaded the data, you cleaned the data, and you visualize the data. What's the next part? You try to build some model so that it will predict something. And for that, you need to build any models, right? For example, if you want to build like CNN, convolution neural network, so we need a TensorFlow library. Okay, scikit-learn, the same thing. It is basically used for building the models. So this you will understand when you are doing the modeling part. TensorFlow and PyTorch, I think both are deep learning frameworks. So they provide tools for deploying machine learning models. So this stuff is related to modeling part. Flask and Django, same. Those are related to the modeling part. So need not to discuss here because when you are doing the modeling part, we can discuss in deep. And this is also not important. And Beautiful Soup and Scrapy, these are also the libraries for web scraping. Web scraping, it is basically a technique that is basically used when you are, collecting the data. But in our, the PDS project, we already provide the data sets, right? So you won't do any web scrapings. But web scraping is basically used to collect the data from any webs, or from any pages. And for that, you need two libraries. One is Beautiful Soup. And next, languages for data science. Okay, this is just the history part, like whatever the languages that are present like before 2000. And coming to statistical computing, yes. So here in this one language, it's very important to know, which is R. We all know about like Java, JavaScript, Python. We are already discussing, but R is very useful, which is related to the statistical part. If you want to know the data science, you there is like 90% of stats involved in the data science. So whatever you are doing, like data collection, data cleaning, visualizing the data, those all comes under the stats part. And that will be done by using R. R is really helpful. So anyone who want to develop their career in data science, it's very important to know about R. And this is big data era. So simply from 2010 to 2020, what are the languages that are present? So if you want information, you can just go through this slide. Languages for data science, Python, we already know about that, and R, Rust and Go. Yeah, Rust and Go. Those are the emerging in large scale data pipelines for their speed and efficiency. So in this contain like all the languages. There is no need not to concentrate on this, but just concentrate on Python. And R is, like in your free time, if you want to explore R, it's really very good, for any machine learning projects, for any data science projects, or in data science interviews, there are like several questions that are asked, based on R. So don't neglect R if you want to develop a data science or AI career. So these are some of the references that are mentioned. I always prefer to go to official Python documentation if you really want to know about something related to Python. And there is another thing like Google's Python class. It's free Python class for beginners. And W3 schools. This we can use if you want like step-by-step exercises for every concept. And Real Python and Free Code Camp Python tutorials. So these are all the resources if you want to learn the Python. Okay, I think that's the end. Coming to the project, Professor, do I need to show the slide or I can just Yeah, yep. So this week, this Friday, yeah. So this Friday, make sure you form the team, and yeah, that's all. And the logo, yeah. So don't forget to make a logo for your team. Okay, that's all. Yeah, we have to create the logo. I mean, you guys need to create the logo. Yeah.
Have a team,
Mm.
you're still looking for people, get your credit for that assignment.
Yes.
Going on the paper.
Yep. Yep.
Right.
Okay.
Um,
So
team members, send a random email to wsuid@wichita.edu
mm,
and, you know, if you can hook up and make a team on your own.
okay.
It's not, we're gonna do random teams anyhow, so you might as well send an email to actually see if they want to. People from the other class too. No limitation to being in this section of the class. And you know, oh yeah, you can have a team with one person.
Yeah.
That,
If you want to do an individual project, you're welcome to do that. Yep. Okay. So any doubts? People in online? Okay. Just 5 minutes. So I'm stopping the recording. Okay. So if there are no doubts, I will just jump into the attendance part.